All right, hello. So this is going to be section 1-1, and the title of the section is Nets and Drawings for Visualizing Geometry. And we're going to go through the notes here. So this is a little bit of review. So we're just going to quickly review what type of figures these are represented. So are these two-dimensional figures or three-dimensional figures? So in number 1, we have this figure, and as you can tell, it is a three-dimensional figure. All right. And reason here is, of course, it's got length, a width, and a height, so it's got 3 dimensions. In figure 2, do you see how there's only 2 dimensions? It's just got a length and a width, so this is a 2-dimensional object. And then figure 3 here, again, we have a length, a width, and it goes backwards. It has a depth, so there's a 3rd dimension to this figure. So we say this is a 3-dimensional figure. Okay. Now, to build some vocabulary for this section, we need to define what a polygon is. So a polygon is a 2-dimensional figure with 3 or more sides, where each side meets exactly 2 other sides at their endpoints. So what's the main idea here? The first main idea is a polygon must be a closed figure where all sides meet and no sides can cross each other. Some types of examples that you might be familiar with are triangles, rectangles, pentagons, hexagons, octagons. These are all types of polygons. All right, so let's use our vocabulary and see if we can underline the correct word that completes each sentence. So number 4 here. A polygon is formed by either 2 or 3 or more straight lines, and the answer is 3. A circle is not a polygon. Okay, and the reason a circle is not is because a circle does not have sides. Okay, it's just one continuous round loop. So is a triangle or rectangle a polygon with 3 sides? Well, a triangle is a polygon with 3 sides because that's by definition a figure with 3 sides. In number 7, the sides of a polygon need to be straight, not curved. Okay. And 2 sides of a polygon must meet at the same point. Okay. So let's see if we can figure this out. Here are 3 examples. Which figures are not polygons? All right. Number 9 is not a polygon. And in particular, it's not a polygon because the side AE is open. This is not a closed polygon. All right, number 10 is not a polygon. And the reason number 10 is not a polygon is because we have sides that cross. All right, number 11 is a polygon, so it is good to go. No sides cross, it's a closed figure, and it is a polygon. All right, let's take a look at our next page here. All right. So let's complete this. We have some more definitions. So a net is a 2-dimensional representation or diagram that you can fold to form a 3-dimensional figure. Okay. We're going to circle a net that you cannot fold into a cube. So if we look at this first figure, notice if you fold this side and this side up, and then these sides up, we can actually get a cube out of it. Same thing with this. If we fold these sides up and we fold this whole side up, we can get another cube. So the one we cannot get to be a cube happens to be this middle one. There's no way I can fold those to make it a cube. Okay. So suppose I fold the net into a cube. What number will be opposite each face? So if I have face 1 here and I fold it up, what will be the opposite side? So it looks like I'm going to have to fold this around. I'm going to move the 6 down, I'm going to move the 3 down, the 5 down, and I'm going to move the 2 over. And it looks like the 1 will be opposite the 6 when I fold it. And then it looks like the 3 will be opposite the 5. And it looks like the 4 will be opposite the 2. when I fold that figure up. Okay, so again, it should look something like this, number 15. All right, so suppose that we do fold the net into a cube. Which number is missing from each view? So here's the 1 and the 5, like we fold there. So what should have been on this view? Well, what's next to the 5 here? The 4. Here's the 2 and the 3, so we connect those things, and it looks like we need the 1 that's going to connect it. And we have the 4 and the 6, the 4 and the 6, and we are missing the 3. Okay. Now what you could do is you could actually try cutting this figure out and folding this into a cube. And let's try a problem, see if we understand what's going on here. So the net at the right folds into the cube shown. What letters will be on the top and right side of the cube? So 4 of the 5 letters will touch some side of face B when the net is folded into a cube. Cross out the letter the side that will not touch B. So notice here's B. When we fold it, obviously C is going to touch it, E is going to touch it, F is going to touch it, and A is already touching it. The side that's not going to touch it is side D. Okay, number 17. Which side of the cube will that letter be on? Circle your answer. So side D will actually be on the opposite side of B. So it would be on the back. All right, we're going to use the net. Which face is to the right of face B? So which is face right here? And how do I know? Well, it's going to be face C. And one explanation might be the following. Okay, the left side of C and the right side of B are the same edge of the cube. Okay, using this net again, which face is on the top of the cube and how do I know? All right, so here's the top of the cube. Again, it needs to touch B eventually. So I'm thinking it's got to be face E. Okay, and one explanation might be the following. So E is going to fold down, as you can see, to become the top of the cube. All right, and let's go to our next page. So let's draw a net from a solid. What is the net for the figure at the right? Label the net in its dimensions. Okay, so here's 20. 3 of the faces are rectangles. Well, we have a rectangle at the bottom, we have a rectangle on this side, we have a rectangle on this side. So I'm thinking 3 faces are going to be rectangles, true. Are 4 faces triangles? Well, the front's a triangle and the back's a triangle, so I'm only getting 2 faces that are triangles, so this is false. The figure has 5 faces in all. Let's count them. The bottom is 1, 2 sides, 3, 4 sides. So I'm getting 5 sides. So this is true. Now write a description of the net. All right, so the net has 3 rectangles. And 2 triangles. That fold to form the figure above. Okay, so which one of these nets could be the figure above? So we want a bottom with 2 rectangles that come off and 2 triangles. That looks like it. We have 1 rectangle, 2 rectangles, 3 rectangles, and that works for that, and we have 2 triangles. That looks good. This one, we have 4 triangles in a rectangle, so that doesn't work. Here we just have a bunch of triangles. That doesn't work. So it looks like it's got to be this figure. And you see how if you folded these rectangles up and folded these triangles up, you would get this figure. Okay, so problem number 3. We're going to try to draw an isometric figure. So an isometric drawing is something that's going to represent this in 3 dimensions, and it's kind of hard to do, but we're going to try it. All right, so the first thing we have to identify is how many edges and vertices this cube has. So we need to count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21, 22, 23, and 24. So this has 24 edges. And it's going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 vertices. Here's the dot paper that we're going to try to graph the isometric curve. So here, this side's already drawn, represents this side here. Notice we need now to draw going this way. So we have 1, 2, 3, 4 dots. So we're going to go 1, 2, 3, 4 dots this way. That's the top side. Okay, bottom side, we need 4 dots. 1, 2, 3, 4. Top face, we need 4 dots. 1, 2, 3, 4. And then the bottom side. 1, 2, 3. Oh, I'm going too far on that one. My apologies. Okay, so let's stop there. Then we have this face that comes down. And 1, 2, 3 here, goes this way. And here is seeing this first box coming up. And there is your first box. Now let's draw the next box. So we've got 1, 2, 3 this way. We've got 1, 2, 3 this way. We've got 1, 2, 3 this way. 1, 2, 3 this way. 1, 2, 3 this way. Then we've got 1, oh, not really that one. So let me erase that as well. Okay, then we've got 1, 2, 3 this way, and we've got 1, 2, 3 this way, and we've got 1, 2, 3 this way. So there's this box. Now our final box, 1, 2, 3 this way. 1, 2, oh, again, I went too far. So we got 1, 2, 3 this way, 1, 2, 3 this way. And it looks like, or did I go up? All right, let me go up first. I'm not drawing the up one. 1, 2, 3 this way. Here we go. 1, 2, 3 this way. 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 And 1, 2, 3 this way. There we go. So this is the isometric drawing at the figure here. All right. So here is another picture. We're going to underline the word that completes the sentence. If I built the figure out of cubes, you would use how many cubes? Okay, let's count. 1, 2, 3, 4, 5, 6, 7, and 8 for the bottom one. You can't see behind there. So we have 8. Cross out the drawing below that is not part of the orthogonal drawing. Okay, so this figure, do we see this in there? I am seeing, is that figure in there someplace? I think I'm seeing it. This one here looks to be right in this figure, so this is good. This is along the top here, so that's in the figure. This is this big one here, so that's in the figure. And this one is not there. This is along the top. Okay, so right here, do you see how this is along the top? This one here is along the right. This one here is along the front. And this one is not there, so we're going to cross it out. Okay, So let's do a lesson check here. So we're going to write dot paper, one view, three views, or none to label the figure. So tell whether each drawing is isometric, orthographic, a net, or none. So this first figure, you see how this is a one view, everything's in one picture, one view, and it's a net. We've decomposed it. This one has 1, 2, 3 views, so this is 3 views. And it's an orthographic view. This one is on dot paper. And it's an isometric view. This one has nothing really, so it's no views, none, and it's nothing special. Okay? So now is your time to check off the vocabulary words you think you understand now, and how do you rate this?